What up? It's your man, Jimmy Chan. All right. So, here it is. We are talking about LabWork 12 answer keys. So, the first one, we're presented with this. So, the best thing to do here is that since there's really no other logs around and everything else, the best thing to do is actually convert this to an exponential form. So, the best way to do it is this. Actually, so this right here is the base, right? So as a base here, it was involved with the x minus 6. Now it's over to the other side. Oops. Now it's going to be involved with that negative 3. Okay? So with the base for the log, now it's going to be the base for the negative 3. Okay? So, boom, done. Well, not done, but to start off with. But what is 6 to the negative 3? What is that really, right? So, with that being said, you know what? Let's leave this here. With that being said, let's take a look at what 6 to the negative 3 is. So, we have x minus 1 is equal to. So 6 to the negative 3. Essentially, this is over 1, right? So 6 doesn't like being on top, so we let it be on the bottom. So it's going to be 1 over 6 to the third. Yay. What does that mean? Well, 6 to the third we can actually find, right? That is going to be 1 over 216. All right, so now this, ladies and gentlemen, is what I actually had to find. So to get x by itself, what do I do? I have to add 1 over to the other side. Okay, cool. So I got x is equal to 1 plus 1 over 216. Okay. Essentially, I'm adding fractions. So my 1 is really just 1 over 1, right? Actually, you know what? Maybe I shouldn't do that. Maybe I should just leave that 1 right there and just say, okay, well, this would just tell me, there we go, that x is equal to 1 over 1 plus 1 over 216. Well, another way of looking at 1 over 1, or 1, would be what? Just saying that x is equal to 216 divided by 216, because 216 divided by 216 is 1, with a denominator of 216, plus 1 over 216. Well, what does that equal to? That's right. X is going to equal to 217 divided by over 216. And that, ladies and gentlemen, is your answer, which is choice C. There we go. There's number 1. Number 2. All right. So, what do I do? Well, we have the power rule because we see a coefficient of 3 in front of ln. So that brings out the power rule here. So I'm going to go ahead and duplicate this part. Duplicate and bring it down, right? And that 3 is now the power, okay? With the power, now what I can do is get rid of ln, right? How do I get rid of ln? That's actually pretty simple as well. You raise it to the e power, or you raise e to the power of, or take e of both sides. How about if I put it that way? E of both sides, okay? So with that being said, what do I have on the left side? I just have, blowing up the picture. I just have the E and the ln, so these two right here are actually opposite operations of each other, so it cancels each other out, okay? So what I actually have now is a 6x to the third is equal to e to the 6th power, okay? Now, how do so this is 6 to the third and x to the third, right? Because it's in parentheses. So what's the opposite operation of to the third power? There's actually two things that you can look at. One is the cube root is the opposite operation of to the third power. Better yet, cube root, so you would typically say the cube root. But cube root can actually be written in exponential form, which is what? Let me do this. Duplicate this just so you guys can see this. I've been going straight up and down. Let me do this here. Okay. So what I can do is actually raise both sides to the 1/3 power. Okay. So therefore, I have 6x is equal to, I don't like this 6. 6x is equal to e to the 2nd power, because when we raise a power to a power, we multiply the power. So 6 times 1/3 is actually equal to 2. So now x is equal to e squared divided by 6. Which, ladies and gentlemen, that is choice C. Now the cube root would work. So don't get me wrong, I won't take away points if you guys decide to use a cube root, as long as you can show me how you got e to the 6 to e squared with that cube root. Okay, so that's choice 2. Choice 3. Okay, I see a bunch of log to the 4th, and typically when I have an equation where the x's are kind of split to both sides, I typically like the x's all on one side. So same thing with the logs, right? And in this case, the logs and the x's are all scattered on both sides. So let's bring them all to the left side, or to one side. So essentially what I have now is a log base 4 of x plus 1. And I'm going to subtract that log base 4 of x minus 4 over to the left side, and that's going to equal to 1. I have a subtraction going on here on the left-hand side. That subtraction, in terms of condensing, it would become log base 4 of x plus 1 over x minus 4 is equal to 1. Ooh, look at what I can do now. Now I can convert this to exponential form. And remember what I said in problem number 1, I can just take this right here, duplicate it, and go boop, right? And since the 4 was the base on this side, is now going to be the base of this side. Okay? How cool is that? All right, so let's see what we got here. So I have x plus 1 over x minus 4 is going to equal the 4 to the first power, which is just 4. Actually 4 over 1, right? So what I actually have now is what does she have that I don't have, right? In order to get rid of the denominators, I would multiply top and bottom here by x minus 4 so that they both have the same denominator. And if they both have the same denominator, if the denominator is the same, that means the numerator is the same. So my new equation is going to be x plus 1 is equal to 4 times x minus 4. Okay, so let's solve. X plus 1 is equal to 4x minus 16. Let's go ahead and subtract the x over and add the 16 over. So x is going to equal to 17 divided by 3, which is choice C. Come on. Come on. There we go. There's choice C. All right, so there's number 3. And on to number 4. Oh no. Now there's logs everywhere. What do I do? What do I do? Oh no, what do I do? Great question. How about we just deal with exactly what's here on the right side? So what we have here is we have log of 4x. And don't get me wrong, if there's no base, right? What is the base? That's right, it's a 10. Is a base of 10 is called common log, right? Over here on the right side, I'm adding. Since I'm adding, that means when I condense, it's going to become multiplication. Well, since the logs are the same, that means what I'm taking the log of must also be the same since these two sides are the same. So therefore, I can just say 4x is equal to 5 times x minus 1. Okay? All right, so that means 4x is equal to 5x minus 5. Let me subtract the 4x over, so I get x, and that is going to add the 5 over, so it's x is equal to 5, which is choice B. There we go. On to number 5. Hey, this looks really familiar, right? I wonder. Now, so this problem here, because the right side was adding, I get to multiply, right? When I condensed, and then I can just get rid of the logs. Look at this one. So this is subtracting, so I would be dividing, so essentially you'll have this, right? Now you are putting a fraction in action for yourself, right? It's like you're putting yourself in harm's way. For what reason, right? Why not be more smarter? Yeah, I said more smarter. Why not add that log of 4 to the right side, right? Because if I did, I'm going to have this, right? Didn't like that 20 for the 24. So that's going to equal to log of 4 plus the log of 7x plus 3. Am I right? Because the log of 4, if I move it to the right side, then now it's going to be adding. Because I had to add it over to the right side. And the log of 7x plus 3 is already positive because there's no sign in front of it, so it must be positive. Now, because the right side is adding, guess what? It's also telling me it's multiplying. So I'm going to have a log of x plus 24 is equal to log of 4 times 7x plus 3. And since they're both log of base 10, they're both common logs, that means that my left and the log of the x plus 24 and the 4 times 7x plus 3 must be the same. So I got x plus 24 is equal to 4 times 7x plus 3. All right, so I got x plus 24 is equal to 28x plus 12. Well, let me subtract that x over, so I get 27x. Subtract the 12 over, I get 12. So that means x is going to equal to 12 over 27, which 12 divided by 27, change the fraction, is 4 over 9. 4 over 9. Actually, let me put it on this side. 4 over 9, which is choice B. It's like you guys have a choice to deal with fractions or division or multiplication, and you guys decided on division just for the sake of playing with fractions. Why would you do that? Don't go chasing waterfalls. Okay, anyways, joking. All right, 6. How about 6? Let's do 6 first before we do 7. All right. Hey, look, it's LNs, but it's adding. That means it's multiplying. Cool. So I have ln of x minus 6 times x plus 1 is equal to ln of x minus 15. Awesome. So since the ln is the same, that means what I'm taking the ln of is also the same. So I got x minus 6, x plus 1 is equal to x minus 15. Oh no, I got to FOIL. So you got FOIL this side, right? And that's going to give me an x squared plus x minus 6x minus 6 is equal to x minus 15. I see an x squared. I see an equal sign. So it must mean I have a quadratic equation. Yeah, that wasn't very good. I know. So anyways, let me see. I subtract the x over. So I'm going to have an x squared minus 6x. Add the 15 over, and I'm going to get a plus 9 is equal to 0. I have to factor the left side, x minus 3, and x minus 3 is equal to 0. So I have x is equal to 3 as one answer. But Houston, we have a problem. Because if I was to plug it in, I would be taking the ln of negative 3 and the ln of negative 12. You're like, why is that a problem, dude? All right, so let's take a look here. Let's change this to a graphing calculator. And let's take a look at what the ln graph looks like. Whoa, functions. None of those. None of those. And none of those. But one of these. So ln of x. Look at what happens, guys. Check this out. Okay? Notice what happens. The x values for a ln function or a log function or any log function, the domain, which is the x values, go from 0 to infinity, but not including 0. So that means you can never find any ln or log of a negative number because the log graph doesn't exist on the negative side of the x values. It involves negative y values and positive y values, but no negative x values. Okay? So you can't take the ln of a negative number. You can't take the log of a negative number. All right? So therefore, this has to be rejected. So therefore, I have no solution, which is choice D. Which is choice D. There we go. All right. That was 6. So on to number 7. All right. So number 7 says, hey, here's my equation. I want to know that what t might be, which is after 2000, if the final amount came out to be 6,639. Okay, so let's go ahead and plug that in. So 6639 is equal to 3,800 e to the 0.062 t. Okay. So first, I'm going to divide that 3,800. Is equal to e to the 0.062 t. Then I'm going to take the ln of both sides. So it's going to be the ln of 6639 over 3800 is equal to, and the ln of e is going to be their opposite operation, so it goes away. So I'm left with 0.062 t. Then my t is going to equal to ln of 6639 over 3800 all over 0.062. All right, so let me try to remember all these numbers. All right, let's see here. Going back to scientific. So I have ln of 6639 divided by 3800. Get over parentheses divided by 0.062. Okay, so that's exactly what I have. I get 8.999. So t is going to equal to 9, which is the number of years after 2000. So therefore, it's going to be 2009, which is choice D. Ooh. Yeah. There we go. And that's number 7. Number 8. You're gonna feel really silly. So if I'm correct, this formula is A is equal to A naught E to the KT. Actually, let me read this first, because maybe I feel silly. Yep, there's exponential growth, so that's correct. But what does K stand for? K, let me highlight K here. K stands for, stands for, that's right, the rate, which is what I was looking for, right? That's exactly what I'm looking for. Remember, there's the rate, and it's going to be in decimals, right? And that if it was positive, it'd be growth. And if it was negative, it would be decay. Right? So, since the rate is already there, right, which the rate is 0.061, and I want to make it to percent, I would move this decimal place twice to the right. So here's the new decimal place. So therefore, my rate is 6.1%. And 6.1% would be B. So not much work here, just observation. See? All right, on to number 9. Half-life takes us 710 years for that silicone 32. How much of 30 grams would be left after 300 years? So obviously 300 isn't half of 710 either, right? So it's kind of an awkward spot, ako taco spot, right? So, but what you have to understand is that this half-life of 710 years plays a part. There's a reason why it gave you that information. It gave you that information because that helps you find something else, right? And we came up with this formula for half-life, right? Which was what? 1/2 is equal to E to the KT. Is that right? So, with that being said, let's plug it in. It's 710 years, so the only thing that's missing is the K, which is exactly what we need. We need to know what kind, at what rate does it decay if the half-life is 710 years, okay? So, that means I got 1/2 is equal to E to the K times 710. Okay. So again, I would just take the ln of both sides. So the ln of 1/2 is equal to 710K, because the ln of E are opposite operations, so they go away. Awesome. So my K, okay, is equal to ln of 1/2 over 710. All right, let's see what that equals to. What did I say it was again? So ln of 1 div 2 over there, parentheses, divided by 710. Whoa, really big number, right? So let me see. 9763. 9763. 763. Is that what I just said? 9763. Okay. 976. Yep. Let's even go 26. Okay. So times 10 to the negative 4, right? That's what it shows. All right. So if that shows that, what does that mean? Right? It means that I would move, number 1 is negative. Number 2, it means I would move this decimal place 4 times to the left. 2, 3, 4. That means all of these needs a placeholder. Okay? So it's actually negative 0.123976626. Okay? Awesome. Well, that's what it means. All right? So, let me see here. Let me see what I want to do here. I guess I could. Oh, that's not the right one. Take that, shrink it a little bit, and put it up here so that you guys can kind of see that work at work. Right? All right, so that is my K. Awesome. Now I can apply that K to what I have here. But because it's giving me an initial amount, right? And it's not it's not 710 years, so it's not half of it. It's not half of a half-life, which we don't know if half of a half-life is actually true either. So we actually can't use the half-life formula, which is 1/2 equals e to the kt. However, we do have to use a is equal to a naught e to the kt, right? Because we're given an initial amount and we want to know how much is left. So A is what we're actually looking for. The initial amount is 30. E to the negative 0.000976626 times, I'll just use parentheses, 300. Okay? Boy, that's rough, right? So, let's go ahead and put in the calculator. So, let me hit enter here. So, I have 30, and I got to multiply by e raised to the power of, now, it was 300. You know what I'm going to do? I'm going to use parentheses here. 300 times that answer that's right above it, right? So I'm going to say ANS. So there it is. So it would give me all the digits without typing all the digits out. So that gave me 22.38. Oops. Oh, that's number 9. Yep. 22.383 even. Okay, so perfect. So that means this is equal to 22.383 years, which is choice. I'm sorry, not years. What am I talking about? It's going to be grams, right? Because it started out with 30 grams. So that is going to be choice B. And there we go. Let me move the B. You got your B. You got your B. All right, that's number 9. Now to number 10. All right, so number 10 is kind of like number 9. Okay, so what is actually happening is that the first part of the information is actually said there to help me find what I need to find in order for me to find the number of years. Okay, so decay and growth has the formula. A is equal to A naught e to the kt, right? Final, initial, k, and t are the unknowns. And hopefully 3 of those things are given to me. So if I was to look at just, 1,000 to 100, I have final amount, I have the initial amount, I'm looking for years, but then what I don't have is the k. But if I look at the blue aspect, right, 9 years, initial amount, final amount, well, that can give me a k. So that means that first part of the 9 years going from 1,500 to 1,000 is actually there to help me find my k. Okay? All right. So A is equal to A naught e to the kt. And that is going to give me my final amount was 1,000, right? Because 9 years later is 1,000. It started at 1,500. E to the k is what I'm looking for, and it took 9 years. Whoa, that's an awful 9. There we go. All right. So then, to get that, I would divide the 1,500 is equal to e to the 9k. Then I'm going to take the ln of both sides. So we're going to have ln of 1,000 over 1,500 is equal to 9k. So my k is going to equal to ln of 1,000 over 1,500 all over 9. Well, let's plug it in. Plug it in, plug it in. So this is going to be ln of 1,000. Is it 1,000? Over 1,500, arrow over, parentheses, divided by 9. Awesome. Okay, where is, so I need to use this. All right, so my K was negative 0.04505. Is that right? 45051678. Okay. All right. Little small, little tiny number here. All right. So now that that is built, now I know what the K is. Now I can go to the second part. It says how many years? Going from 1,000 to 100. So I got my final amount. I have my initial amount. So again, I'm going to go ahead and use this right here. Might as well bring this down, right? So this is what I'm using. So I have my final, which is 100. I got my initial, which is 1,000. E to the negative 0.045051678 times t, right? So again, I gotta find my t anyway. So same thing, divide the 1,000. So I'm going to have 100 divided by 1,000. And that's going to equal to e to the negative 0.4505 blah, 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 t. So take the ln of both sides. So I'm going to have ln of 100 over 1,000 is equal to negative 0. Uh-oh. I missed a digit over here. Negative 0.04505 ... t, right? So it's negative 0.045051678 t. Okay? So now my t is going to equal to ln of 100 divided by 1,000 divided by negative 0.045051678 ... Okay? So let's see what my t is. All right. So here I'm going to hit enter. So I need to do, what was it? Function ln of 100 divided by 1,000. Toggle over parentheses and divide that by this previous answer right here. So ANS, boom, 51.1. Now, here's something to think about here. Let's look at this. So negative 0.04, know how to give you 57 years. 505. 1, 6, 7, 8. Notice how it slowly gets closer and closer to that 51. Okay, so either way, it is 51. So t is equal to 51 years. And that, ladies and gentlemen, is choice A. There you go. All right, if you guys have any questions, let me know. This is the completion of LabWork 12 answer key. See ya later.